Might be with the 8th video and the bounce modulator mixer messing with the power supply series. The 250 volt power supply that feeds the transmit receive mixer and the final driver had 1.2 volts AC ripple on the 250 volt supply, and that's not much with regard to 250, but it was a lot compared to the very small RF signal, and they were being AM mixed. So I broke the B plus supply to those two plate resistors for those two tubes and put a 150 ohm resistor in series with, and then to ground a 100 microfarad 300 volt capacitor. Let's drop the AC ripple down to, that's 50 millivolts per division, so about 30 millivolts. That's real clean. Sweep out to the 250 volt level, nothing. Dead flat. But that is not the end of the problems, because the problem remains that there is carrier leakage, and at the final grids, after the final driver amplifier, there is a 6 volt peak to peak carrier. Nice, pretty clean carrier. That's about as nice a carrier wave as you could want to see. It shouldn't be there. Not 6 volts, not none, because the transmitter gain is turned all the way down. So that's carrier leakage. It cannot be coming from the diodes and resistors I put on the circuit board because they're perfect. But it's probably, my guess is that T14 is out of adjustment. In the manual it says if the carrier balance pot has to be turned more than one turn, then realigning T14 is necessary. And my guess is that it's because I haven't adjusted that transformer. So what this experiment with the power supply shows is that the power supply was causing a lot of the ripple on the signal, and that was AM. That wasn't from the bounce modulator. So the question is, what's coming out of the bounce modulator with carrier drive? With in sideband, not with carrier drive, but with modulation drive. And a modulating signal of 500 cycles, 220 millivolts into the mic jack. The mic jack input will go about 300 millivolts. Over that, the transmitter starts oscillating. So there's about a maximum level for microphone input. But when I turn up the modulation signal with the transmitter on, I get that. And that is kind of what we got before, although it doesn't have the AC ripple superimposed. But I turn it up, and instead of getting what should be just an envelope, I get what looks like a two-tone. Oh yeah, but what does that mean? Does it really matter? It's only 5 volts on the grid of the finals. Those finals should swing at least 100 volts RF swing, maybe more. Does it really matter? Well, yes it does, because I'll show you why. Screen dark. There's the output from the Yaesu speaker. The Yaesu being used as a monitor receiver, picking up signal through the TR3 chassis. There's key down in sideband. Receiver tuned at 7.3 megahertz. TR3 tuned at 7.3. Nothing. When I tune the Yaesu down, I get a single tone, which is the carrier. Right on frequency, the carrier is coming through the RF mixer, which is generating 7.3 megahertz going to the final amplifier. That would be okay in CW, but this is sideband. There shouldn't be anything. When the modulation is turned up, something ugly happens. On frequency, tuning down, here comes the carrier. Here's some distortion. There's the carrier. That's 7.3, 7299990, 80, 70, 60, and at 7299950, where that modulation signal is, here's what happens at 7299960. There comes the modulation signal. So there's a two-tone. And at 72988, at 7299, a kC up, it starts again. So every 500 kC, there's another tone. So that is not clean. And FCC expects us to have clean transmitters. That's the entire purpose of amateur radio. It's not amateur CB. It's not close is good enough. We're supposed to know enough about radio to know how to resolve these things. So there was the Yaesu, got the Yaesu speaker, here's the Yaesu antenna coax with a jumper wire. Had the AGC off on the Yaesu. So just acting as a local monitor receiver. And the final amplifier in the TR3 is turned off, so it's picking up driver signal. But at least it's better, because that 60 cycle trash, or that 120 cycle trash from the 250 volt supply is not in there also modulating it. Here's the signal generator, 500 hertz, second order harmonic, same amplitude, 500 hertz. Pretty poor looking waveform. It didn't look real good last time. But notice this time, if you go back and watch the previous videos before I fixed the power supply and put in a new modulator, the envelope wasn't nearly this clean. So something has changed bigly in putting in the new balanced modulator circuit. See, as the modulation increases, it comes closer to a better looking signal. But it still is not right. Most operators probably won't notice it on the air, especially with noise, but it's not right. So next off, to make it right, and hopefully it's just adjusting T14 a little bit, KBYP.